Hello everyone, welcome to Integration C2 Part 1. What we're going to do is introduce integration, you take an algebraic approach, and later on in Part 2 we'll look at some graphs. Let's just recap some differentiation, and I like to think of a staircase when I do this. So say we've got an fx equals x to the power 4 plus 3x squared. Okay. Now, when we differentiate that, we call it f prime x, and we get 4x cubed plus 6x. Now, if we differentiate this, we get f prime prime x, and this gives us 12x squared plus 6. So as we go down the staircase, we can keep on going down and keep on differentiating as we go down. Now, this process here, let's call this differentiation, which it is, and integration is essentially the reverse process. So integration takes us back up the staircase. So that's one way to look at it. So let's take an example. If we've got fx equals 6x squared plus 10, then f prime x gives us 12x. Agreed? Right. If I'm going to integrate 12x to go back to fx, this is how it's done. I write a long symbol like that, that's called the integration sign, and I write my f prime x dx. And the dx tells me that I'm going to integrate with respect to x, and then this gives me fx, which is my original function, plus c, and this c is called the constant of integration. So say we've got 12x dx. This would give me 12, I take my x, I raise the power by 1, so I've got 1, I add 1 to it, and I divide it by that raised power, and that's it. And then I add my constant of integration plus c. So now this gives me 12 over 2, which is 6x squared, plus some constant c. Later on we'll find out how we can work out this arbitrary constant, c, the constant of integration. And I guess that makes sense because the 6x squared, instead of 10, if I had that quadratic plus 20, when I differentiate it, we still get the 12x. If that's 30, we still get the 12x. So when we integrate, we have a number of solutions, and they depend on that constant c. They're all valid. But once we have some more information about the graph, we can work out what that c actually is. So in summary, the rule goes like this. If we will integrate ax to the power n dx, you might want to pause the video and see if we can come out with a general rule. We take ax, you raise it by the power 1, divide by that raised power, and the same with any other terms, and then you add that constant of integration plus c, which is normally worth a mark in an exam. Okay, as practice, let's have a go at these three examples. You might want to watch the first example, then have a go at the other two yourself. So we've got dy of dx is x cubed plus 3x plus 2. So let's integrate that. So let's put x cubed plus 3x take away 2 dx. Let's raise the power by 1. So you've got x to the power 4 divided by 4 plus 3x squared divided by 2 minus 2x, and then don't forget the plus c, constant integration. So that's integrated. Part 2. Oops, let's bring that up a bit. Okay, here we go. Right, part 2. We want to integrate 4x squared minus 5x take away 1. So use the integration sign. 4x squared take away 5x take away 1 dx. And we raise the power by 1. divided by that raised power, raise the power by 1 again, divided by that raised power, and that minus 1 becomes x. One way to think about it is that minus 1, you've got x to the power 0 next to it, so when you raise it by the power 1, you become 0 to 1, and then you've got obviously the plus c. Finally, when you've got something like this, you want to integrate x plus 3 and x minus 2, you've got to expand it out so you can do it term by term. So we've got x squared plus 3x take away 2x gives us x, take away 6, okay, and we have dx. We then raise the power by 1, so you've got x cubed over 3 plus x squared over 2, take away 6x, and then you've also got plus c. Okay, let's now look at a case where we've been given the gradient of a curve, which is u of dx, and this time we've been told a point which it passes through, this curve passes through. Now we can use this information to find that constant of integration plus c. So let's see how this works. We're going to find the equation of the curve, firstly by integrating our x squared, 2x plus 1 dx. Okay, so we've got x squared there. And then that gives us 2x cubed plus x squared. And that constant, so that's expanded out. So we've got 2x cubed plus x squared. So that's what we're going to integrate. And so we do 2x to the power 4 divided by 4 plus x cubed divided by 3 plus that constant of integration c. So this is now our fx. We can maybe tidy this up just by putting that in a simpler form. So you've got x to the power 4 over 2 plus x cubed over 3 plus c. So let's put that down as fx. Now we've got another bit of information, and that's that when x equals 1, y equals 5. So let's substitute that in. So f of 1, so if I put 1 in here, plus 1 over 3 plus c, all of this equals 5. We can now rearrange this whole thing to work out what c is going to be. So 5 take away a half, take away a third, equals c. So that should give us 25 divided by 6. So therefore fx or y, so it follows fx equals x to the power 4 over 2 plus x cubed over 3 plus 25 over 6. So here's an example, let me just go over this again, where we've been given a gradient of a function, and this time we've been told a point the curve passes through. And so therefore when we end up with this constant of integration for this curve, because we know an x and corresponding y value, we can substitute that in and work out what this constant of integration is going to be. And so we can have an exact value or more precise definition of the actual curve. Okay, let's look at a bit of a practical example. Here we've got the velocity of a particle is given, leaving at point P is given by v equals 3t plus 1. And we want to find the displacement from P after 3 seconds, so they've given us the value of t. Now something to point out from the very beginning is the relationship between displacement, velocity and acceleration. If x is our displacement, some books use s for displacement, then velocity is the rate of change of displacement. So you've got dx over dt, and this gives us our velocity. And it's also worth noting that acceleration is the rate of change of velocity. I'm putting those lines on top because it's a vector. Those of you who are going to do M1 will come and look at that in more detail. So with dv over dt we've got acceleration, but we've just said that velocity is dx over dt. So one of the things we can do is differentiate the dx over dt again, and that gives us our velocity as well. Acceleration as well. So that's a relationship between displacement, velocity, and acceleration. You differentiate one to get the other, and so that also means to go the other way we just need to integrate. So let's do that. We've got velocity and we want to find displacement, so we can integrate 3t plus 1. Now this time over here, when we integrate, we shouldn't put an x down. The reason being, our variable is in terms of t, and that's what we're integrating. So what we need to put down is a dt. Let's integrate that. So we get 3t raised to the power by 1, 3t squared divided by 2 plus t, and add our constant of integration. So there's an expression for our displacement x. Now we need to find the displacement of the particle at from point P after 3 seconds. So let's put in a value for t as 3. Now maybe before we do that, we need to sort out this constant of integration over here, this c. And one of the things we know is that the particle passes through P when t equals 0. So let me just write that down. So the particle passes through P when t equals 0. So therefore, when you've got 0 displacement, if we put 0 in there, so 0 equals 3 over 2, 0 squared plus 0 plus c, and so therefore c equals 0. Now if we then substitute t equals 3, then so we've got 3 over 2, 3 squared plus 3 plus c equals our displacement. Sorry, that c shouldn't be there because we've just found out that equals 0. And so that should give us 9 times 3, 27 over 2 plus 3. So it should be 16.5. So therefore our displacement is 16.5. Okay, let's end with a little test question. Let me write that down here. And what I'd like you to do is, for the curve, for a curve with the gradient dy of dx equals 3x cubed plus 5x squared plus 6x plus 10, which passes through the point 1, 2. What I'd like you to do is work out the equation of the curve and find the constant of integration c. So find the value of the constant of integration c. And there should be a form attached to this if you're watching this from my website. And in that case, please enter the value of c on that form. Bye for now.